Okay, guys, so now we are going to be talking about our solving by elimination. So for this one, we're going to go through our steps again like we did for substitution, but we're going to have our simple ones and then our more in-depth ones that I think will help y'all more. So our first steps are to make sure equations are lined up. Then we're going to add or subtract equations to eliminate the variable. After that, we're going to solve the equation for the remaining variable. And then we're going to substitute your answer into either equation and solve for the other variable. So these sound really similar to your substitution methods. So that's okay. So next thing that we're doing is elimination is a method for solving systems of equations that involves adding the multiple of one equation to the multiple of another equation. So this is our more in-depth notes, guys. This is going to be the elimination and everything like that. So our different steps are going to be multiply one or both of the equations by a constant to obtain a coefficient that differ only in sign. So we need one to be negative and one to be positive for one of the variables. Then we're going to add the revised equations with the goal of eliminating one of the variables. Then you're going to simplify and solve, which, if you notice, is very similar to our substitution steps. Then you're going to substitute the value found in 3 into either of the original equations to solve for the remaining variable. Last one is going to be writing our solution in our ordered pair. So we're going to go through and do that exact thing. Just like we did before, we have each of our different steps right next to it. So we've got 1, 2, 3, 4, and 5. So y'all can see that we're doing in the same thing that the step is asking for. So the first thing, it says multiply one or both of the equations by a constant to obtain coefficients that differ only in one sign. Okay, so I'm going to look at my difference here. So the only difference between my x and my 3x is the 3, and that it's positive. So if I wanted to make my x the opposite of it, I'd need to multiply by negative 3 to have it be the opposite but still be a part of 3. So I'm going to be multiplying by negative 3. That's going to give me negative 3x plus 6y equals negative 3 because I distributed that negative 3 into all 3 equations. So then I'm going to add 3x plus y equals 31. As you can see, that's our second equation right here. And they're opposites now. My 3x and my negative 3 are opposites. So then I'm going to add the revised equations with the goal of eliminating 1. That's our second one. So if I add these together, I'm going to cancel out. My 3x is here, and I end up with 7y equals 28 because I have my 6y plus y and then my negative 3 plus 31. So then I get on to step 3, and I'm going to take this equation, 7y equals 28, and I'm going to simplify and solve for that variable. So I'm going to try to get y by itself. So I'm going to divide by 7, and I get y equals 4. So that's my answer right now. So then I go to step 4. And that's going to be to substitute the value found in the previous equation, that's our 4, into either of the original equations. So I'm going to choose the one that has less coefficients. So I'm going to do x minus 2y equals 1. And I'm going to plug in my 4 into that y. So I'm going to get x minus 2 times 4 equals 1. And that's going to lead me to x equals negative 8 equals 1. I'm going to plus my 8 onto both sides, and I'm going to get x equals 9. And my last and final step is always to write my solution as an ordered pair, which, remember, our ordered pair is xy, so that means I'm going to have 9, 4 as my solution for this equation. Okay, so now we have 6 examples that we're going to go through so we can make sure we understand elimination. So first thing, we want to make sure that they're even. As you can see on here, they're completely even. So we're now going to try to make my x, because it's the first one on there, opposite and but equal to our 3. So that's going to make me multiply by negative 3, and I'm going to distribute that in all the way through. So that's going to give me negative 3x plus 3y equals negative 6. And then I'm going to bring down this second equation, which will be 3x plus 3y equals negative 12. So this right here was step 1. Now, step 2 is going to be adding these together. So that means these are going to cancel, and I'll end up with 6y equals negative 18. Step 3 is going to be solving for that y. So I'm going to divide by 6 on both sides, and I'm going to get y equals negative 3. And that's going to be my first variable. So from there, I'm going to go to step 4, which is plugging in this variable into one of my equations. So I'm going to do x minus y equals 2. I'm going to plug in my negative 3 there. So I'm going to get x minus negative 3 equals 2. Those can cancel, and I'm going to get x plus 3 equals 2 minus my 3 on both sides. And I end up with x equals negative 1. So my last step, number 5, is always to put it in an ordered pair. So I get negative 1, negative 3 as my ordered pair. Okay, so now we move on to number 2. If you'll notice already on this one, I already have it as 6x and 6x. The only thing it has to be now is opposite. So in this bottom equation, I'm just going to multiply this entire thing by negative 1. So I'm going to distribute that in all the way across, and I get negative 6x plus 7y, because negative is negative, equals 20. And then I'm going to bring down my first equation. So it's 6x plus 5y equals 20. So second step, I'm going to add these two together, and I get that canceled. Then I get 12y equals, apologize for the mistake, that needs to be a 4 on the second one. So I have 20 and 4, and that's going to give me 24. So then I'm going to do my third step and divide by 12, and I get y equals 2. So then my 2 is going to plug back into one of the equations. So this is my fourth step. So it's going to be 6x plus 5 times 2. We're dropping that into the y equals 4. So then I get 6x plus 10 equals 4. Minus 10 onto both sides, so the x are by themselves. And you get 6x equals negative 6. Divide by 6 to get my x by itself. And I get x equals negative 1. Last step, we put it into a solution, and we're going to have negative 1, 2. And that's our new solution with our ordered pair. So now we're going to move on to the next one. So our next one looks really easy. It already has opposites here and here. So now we're just going to solve since it already is there. So if I add these together, that's going to cancel and that's going to cancel, which is going to give me 0 on this side. When I add those two together, negative 4 and 2, I end up with negative 2. But 0 and negative 2, they're not equal to each other. So that means it's not true. And when something's not true, just like our graphing and our substitution, it means we have no solutions. So this one's super easy. Now we're going to look at the same thing on example 2. If you look at our first ones, they're already opposite and ready for us. So we can skip to our second step, which is adding them together. So we know these two are going to cancel. And so is the 5 and the 5y and negative 5y. So that gives me 0. Then we have our equal sign, and we have 20 and negative 20, which is also going to cancel. So we have 0 equals 0. Well, this one is true because 0 does in fact equal 0. So we have it as true, which means, if you remember from our graphing and our substitution, that we have infinity solutions. So infinitely many solutions, or infinite solutions. Any of these are great ways to answer it, and I'm okay with either of the three choices, either infinitely many solutions, or infinite solutions. So we have 2 more problems. So this is going to be a little different because we have to solve by fractions. So you have to add this extra little step in, and it's multiplied by the common denominator. Then you can solve using the other steps. So remember, our common denominator is our low-end number in the fraction. So we're going to multiply this first one right here by 3. And that's going to give me x plus 3y equals 5. Because I distributed in that 3 on each one and multiplied 3 by each fraction and by each term. Then I'm going to drop down my x plus 6y equals 14. Well, one of these has got to be turned opposite. So if I multiply this entire equation by a negative 1, I'm going to end up with negative x, negative 6, negative 14. And that's great, because then we're going to add those together. So our x's are going to cancel. I'm going to end up with negative 3y, and I'm going to end up with a negative 9. From here, I've got to simplify for y, so I'm going to divide by negative 3, and I get y equals 3. Now I'm going to plug my y in. I don't want to deal with fractions again, so I'm just going to do that second equation. X plus 6y equals 14, and I'm going to plug in my 3 for that y. So I end up with x plus 6 times 3 equals 14, which is 18 equals 14. I'm going to subtract my 18 from both sides, and I'm going to end up with x equals negative 4. So my final solution is going to be negative 4, 3. So the last one, we're going to do the same thing. So our first equation is fine. We don't have to worry about it. But our second equation, we've got to deal with that denominator. So we're going to multiply by 2 because our common denominator is 2. We're going to distribute our 2 into all 3 places. And we should end up with negative 2x minus y equals 12. Well, before you even do anything, you can notice on the first equation that we have a positive y, so they're already opposites. So all we have to do is write down our next equation, equals negative 26. Now we can go straight to step 2, which is adding these 2 equations together. So our y's are going to cancel, and then we're going to end up with 7x equals negative 14, because negative 26 plus 12. So now we're on the third step. We're going to solve for x, and we get x equals negative 2. So that was that third step. So our fourth step, we're going to plug x into our first equation. So we have 9x plus y equals negative 26. So I'm going to drop that x right in here, and I get 9 times negative 2 plus y equals negative 26. That gives me negative 18 plus y equals negative 26. Then I'm going to add 18 to both sides, and I get y equals negative 8. So my final equation is going to be negative 2, negative 8. So that, guys, is how we do elimination. If you have any more questions after watching these and going through